Good morning, and welcome to Computer Science 311. Computer Science 311. Okay, and if the calendar serves me well, this should be a lecture that you should be listening to, looking at on Monday, and I think that's October 2nd. Okay, and the subject of today's talk is linked lists. And in your book, you should be reading chapter 5. And they're going to be, I don't know, they're probably going to be 2 of these videos, maybe 3. It all depends how I feel. I like to break these up into smaller videos so that each one is not too long. We'll see how that goes. But here is the basic idea. You already recall, I think when we met last week, that I talked to you about memory in your program. So this is memory. I should say it's program memory. And when you come along in your program and you say things like int a is equal to 56, or if you come in here and you say char c is equal to x, we said that there is some memory is actually broken up into 2 pieces, and there's something called a stack, which grows this way, and there's something down here called a heap, which grows up this way. The way they grow doesn't really matter. The important thing here is that these are separate places in memory where separate memory allocation goes on. Now, for example, when I have primitive data types, and these are primitive data types right over here, and I come along and I say A, we go into the stack, and what happens is we might say, well, here's A, and the number 56 is in there. Now remember, these are memory locations, and memory tends to look like an array. So there's some starting memory address over here, and I'm just going to make this up, and I'm going to say, gee, this is 1000, and maybe this is 1001, and this is 1002, and it keeps going, and maybe we get down to here, and maybe down here the heap is at 9999, and it goes backwards that way. These are completely arbitrary. I just made them up. So if that's A, and I come over here and C is X, so that means I'd come over here to the stack, and I would put a C in here, and that's an X like that. Now, the last time we met in class, I went into a little more detail about how the stack works. And when you start nesting things, if you come in here and you say int x and you close this up, that again, this gets allocated on the heap, or I'm sorry, this gets allocated on the stack. And we talked about that when you call other methods, you start allocating on the stack. And when the methods are finished, we delete the stuff off of the stack. But again, the primitive data types go here. Now, we also talked about the heap and objects. So I want to make an object up here. And I'm going to call this object a node. And we're going to say that a node is made up of a string that we'll call name. And it's going to be made up of an integer that we'll call age. And here's the thing that's going to be different, and this is where the whole theory of linked lists come in. There's also going to be a node in here, and it's going to be called next. So that when I allocate a node, there are really 3 pieces to it. There's the name, there's the age, And then there's this thing called next. Now, the thing that already seems strange is that inside of this node, I'm declaring a node. And Java lets you do that. To save myself time, I've actually already gone ahead and I have declared a node, and we're going to bounce back and forth between these two screens here. But at this point, I just want you to focus on these 4 lines right here. I'm saying public class node, and then I'm going ahead and I'm declaring the 3 instance variables that make up a node. And you see it right there. And again, the strange thing is that inside of this thing called node, I have declared something called node. Okay? Now, if I come over here, and again, I believe we talked about this in class. If I come over here and I say node n is equal to new node, and maybe I have a constructor here, and I'm going to say it's Bill, and let me get rid of that just to avoid confusion. That was from something else. Okay, whenever we use the word new, that means that we're allocating from the heap. Now, this is assuming, when I make a statement like this, that I've already declared this variable type, or this class called node, and this, of course, is also assuming that there's a constructor. And so what is going to happen is the node is made up of these 3 pieces over here. So it's going to come over here and it's going to go, I've got to find memory big enough to hold these 3 pieces. And it says, oh, I have found it right here. So that's 9998, and this is 9997. And it says, starting at 9997, I have the 3 slots available to me to hold on to these 3 pieces of information. That is what this call returns. This call actually returns the number 9997. It's a memory location where I can start storing an instance of this object. Now what happens over here is I'm storing that in a variable called n. Now this n gets allocated on the stack, and it's going to be right over here. So at n, I have the value 9997. And schematically, the way that we frequently draw this is we put a dot here, we come down here, and we say that it's really referencing this variable right over here. Now, if we go back and look at our constructor, okay, when I called it with Bill in 23, it's basically putting Bill into this thing called name, and it's putting 23 into this thing called age, and it's putting next, it's setting it to null, which means that it doesn't reference anything. So coming back over here, what would happen here is it would put Bill here, and it would put a 23 here, and there's a null in here, and I'm going to represent null. I'll use several different ways to do it, but I'm just going to come in there right now, and I'm just going to put that in there. Okay? Now, if I came along here, let me get rid of that. And what I want to do is I want to declare another node. So I'm going to come over here, and I'm going to say node m is equal to new node. And I'll come over here, and I'll say Sue 29. Now what we've seen from our constructor, what's going to happen over here, we're going to go into the heap, we're going to look for more memory. So here's 9996, 9995, 9994. And we saw, just like we did with Bill, it's going to fill these things in. So it's going to come up here to 9994. And it's going to put Sue in here. It's going to put 29 in here. And the reference to next is going to have a null value in it. But again, remember, this new over here is going to return the value 9994. And it's going to put it in this value M, which is allocated over here on the stack. Think about that for a moment. I'm going to come over here and erase this. And why don't we create one more of these? So I'm going to come over here and I am going to say node P is equal to new node Mike 25. And again, I come over here. Again, I'm growing up in the heap. 9993, 9992, 9991. And again, what this is going to do is 1, 2, 3. It's going to put Mike in here. And it's going to put a 25 in here. And it's going to put a null value in there. And over here is P. And in P, I am going to have the value 9991. So I hope everybody's okay with this picture here. So far, so good. Now, I want to go back and look at this declaration here of this thing node. So far, we're okay on these three instance variables. And again, I hope we're okay on this constructor right here. I hope that makes sense. And what I've done here is I've created a toString, because what I'd like to be able to do is I'd like to be able to print out nodes. And typically when we've done object-oriented programming before, we very frequently have getters and setters for these three instance variables. And we would probably do that here, but the one that I'm most interested in is this thing over here, this reference called next. And basically I want a getter and a setter for that. So notice over here, okay, I have a setter, set next, and what I do is I pass it a reference to a person. So I just say next is equal to P. And over here I have a getter. And what the getter does is it just returns whatever the value of that reference is. So the only ones that I'm interested in, and this is just for the demonstration that I'm giving you here right now, is that I have a getter and setter for the reference. Because what I want to do over here is I want to do something a little bit different that might seem a little bit strange to you. Okay, so I want to come over here and I want to take this reference here, and I would like it to change so that it references this thing over here. So this thing over here is referenced by P. Again, I should update this picture a little bit, and if I did that, this would come over here. And it would point over there. And this one over here would come over and it would point over there. So what I want to do is I want to take the reference from P. I want to see P dot set next. So what I want to do is I want to come over here and follow this reference to P, and this is next here. Remember, this is name, this is age, this is next. And what I want to do is I want to set it to point at this thing down here. Well, That's saying this value right here. If I were to say p.setNext and I were to come over here, n. Okay, now first of all, remember n has this reference in it, 9997. And what I'm doing is I'm saying, come to where p is referencing, and p is referencing this over here, and this is next. Remember, this is age, this is name. And basically what I'm saying is change this value from this to whatever n is, 9997. So if you want to, you could think of this thing over here as doing that. And now what I'd like to do, I want to do something else. I want to change this one over here. Well, remember, that is n, so I want to say n dot set next. So that means I want to change this guy down here. And what do I want to change it to? I want to change it to Su290. Well, that's what m is. So I'm going to come over here and say m. And let's think about how the picture gets updated now. So that's n.setNext. So this changes now. And I've set it to m. M is 9994. So this is 9994. So that means now that this references right there. And I want you to think about that diagram. Look at it for a moment while I do some erasing. And now I want to do something very clever. I'm going to come over here and I'm going to have something, and I'm going to say node rover. Rover's like a dog. He moves around. This guy's going to move around as well. And let me see. I want to let rover equal to p. Okay, and then I'm going to come over here and I'm going to write the following loop, and I'm going to say while rover doesn't equal null, I'm going to say system.out.println rover, and then I'm going to say rover is equal to rover.getNext. So first of all, let's think about a couple of things here. Let's think about how this is going to execute. I'm going to try and keep all sorts of things up on the screen. Hang on here. Okay, so first of all, initially rover is set equal to p. Let's move this over. Well, p is 9991. So first of all, rover will contain the value 9991. So it says, well, rover doesn't equal null. System.out.println rover. First of all, let's just remind ourselves that I have a toString method here. And what it's going to do is it will print out the name and the age. So I come back over here And 9991 is going to come over here and it's going to print out Mike and 25. Now what is going to happen as I come over here is rover gets set to rover.getNext. Well, I come over here and rover was 9991. I get next, well, that's 9997. So now rover becomes 9997, which is not null. And I do a system.out.println. Well, that's going to print out Bill and 23. And then rover is equal to rover.getNext. Well, getting next over there would make this 9994. So this becomes 4. That is not null. Okay, so it's going to go to 9994 and it's going to print out this node, and that's going to be Sue and 29. And then rover gets rover.getNext. Well, look at what the value is there. It's null. So now this is false, and I jump out of the loop. And here is the output of this loop right over here. So why don't we do something like that? I just want you to watch this in action. So first of all, you can see here is my node, and I'm going to come over here and I'm going to say File, New, and I'm going to say Class, and I'll say something like test list, linked list. So I'm going to come over here. Give me a moment while I move things on my desk. And I'm going to come in here and I'm going to say public static void main args. And I'm going to come in here and I'm going to say node A equals new node Bill 23. I'm going to come in here and I'm going to say node B is equal to new node Sue 33. And I'm going to come over here and I'm going to say node C equals new node Mike 28. And I'm going to come over here and let's see. Let's let Bill be at the front, and we'll put Mike in the middle, and we'll put Sue in the end. So I'm going to come over here, and I am going to say A dot set next to C, and I'm going to come over here, and I'm going to say C dot set next to B. Giving me errors here. Let me see why. Set next. Did I do that right? Person P void. Why? Oh, this shouldn't be a person. This is a node. That makes sense. Now the errors are gone. And now I'm going to come over here and I'm going to say something like the following. So I'm going to say node rover equals A. And then I'm going to come over here and I'm going to say while rover doesn't equal null, And then what I have to do is I have to advance rover. So I say let rover equal rover dot get next. Just like that. And I'm getting an error here. Again, this needs to be changed to a node. Now the error should be gone. There we go. And let's watch this run. And why am I getting an error? Greetings. I'm not sure why I was getting that error, but I just hit run again, and notice here down at the bottom, I've got the output right here, Bill, Mike, Sue. Notice what we did here is I said A dot set next to C, C dot set next to B. I could play around with that. I could say A not set next to B, and then I could come over here and say B not set next to C, and I'll get a different output. And let's run that one more time. And now we can see that it went from Bill to Sue to Mike. Okay, so by playing around with the set next, we can play around with the order of these. So I would ask that you look this over here and here. And that will be the end of this video, and we'll get on to the next one where we will generalize this a bit more.